Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll tell you how to implement AOI logic using NOR gates. So here, AOI stands for AND or inverter logic. So generally, when we implement any circuit, we implement by using AND gate in terms of sum of product or product of sum. So we need AND gate, OR gate and inverters. Then NAND gate and NOR gate are called as universal gates because we can implement any circuit using only NOR gate or only NAND gate. Remember, out of NOND and NOR, NAND implementation is more popular because NOR gate consumes more power as compared to NAND gate, and that is why people prefer NAND over NOR gate. But here, you should know how to implement any AOI logic using NOR gate. So I'll tell you how to implement it. And why to implement it? Because if I have one equation, let's say y is equals to AB plus C bar. What I have here, I have AND gate, this plus is OR gate, and here I have inverter. I need to take one AND gate IC, one OR gate IC and one inverter IC. But if I'll implement this logic using only NOR gates, then I need to take only NOR gate IC, so that it will save the space on the board. Instead of connecting three different ICs, now I am connecting only one IC. I am using only one IC. So here you should know some rules. Add bubble at the output of OR gate and input of AND gate. This is first rule. Then add inverter near bubble because we can't change the functionality. If I'll add inverter bubble at the output of OR, it becomes NOR, but I want function as OR. So add inverter near bubble. So we need to add inverter so that the functionality will remain same. See, if I have OR gate, this is my OR gate, A, B. Here what I'll get? A plus B. If I'll add inverter here, it will become AB bar. By putting inverter here, again what I'll get? I'll get A plus B or double bar, that is A plus B. So first step is to add inverter bubble, then add inverter. Then check if two inverters are in series. Then see A, if I have two inverters in series, then what it becomes? Here I'll get A bar and here again I'll get A. So I can remove both of them and then replace gates with NOR gate. So I'll implement this logic. Y is equals to AB plus C bar. So first I'll draw it using simple AND and OR gates. So this is my diagram. AB, here I'll get AB, here I'll get C bar, AB plus C bar. Y is equals to AB plus C bar. First step is add add bubble at the output of OR and input of AND. So I'll redraw the same diagram with bubbles. A, B inputs. I'll add bubbles at the input of AND gate. Bubble, bubble. Inverter will remain same. And add bubble at the output of OR gate. Here we'll get Y. So we have added bubbles. Then why to add bubbles at the input of AND gate? See, what is NOR gate? NOR gate is A plus B whole bar. And if I'll apply De Morgan's theorem here, then it becomes A bar into B bar. So bubbled AND is equivalent to NOR gate. A bar here, because of this bubble I'll get A bar, here I'll get B bar, and multiplication of two of them, this is equivalent to NOR gate. Now rule number 2, apply inverter near the bubble. So here I'll apply two inverters and here I'll add one inverter. So this is my first inverter A. For B also I'll add one inverter. And then bubble and for C, normal inverter. Here is a bubble which we have added. So I'll add one inverter here, and here we'll get our output Y. Now let's check if there are two inverters in series. So we don't have any two inverters in series. So what we'll do, next step is replace gates with NOR gates. So here we can replace this with NOR gate, and we need to replace on all inverters with NOR gate. So the truth table of NOR gate is 2 input NOR A, B, Y, 0, 0, 0, 1, 1, 0, 1, 1. In OR gate, 0 plus 0 is 0 and NOR is inversion of that. So here 0 plus 0 is 1 and remaining are 0, because in OR gate 0 plus 1 is 1. Inverted version of 1 is 0. So here you can see when both inputs are 0, output is 1. When both inputs are 1, output is 0. So if I will use NOR gate and if I'll short both the inputs, then here I'll get A bar. If this is 0, 0, 0, then I'll get 1. And if this is 1, 1, I'll get 0. So I will replace these inverters with this shorted inputs of NOR gate. So let's follow the last step. For this inverter, I'll use NOR with inputs shorted. Here for B also I'll use NOR with inputs shorted. For C also I'll use NOR with shorted inputs. Then here this I'll replace with NOR gate. Then this output and this are inputs to NOR gate, and again we need to replace this inverter with one more NOR gate, inputs shorted, and here we will get our output Y. So in this way we can implement this AOI logic AB plus C bar using only NOR gates. In another video I have implemented same circuit using NAND gates, and in that video you can see only 2 NAND gates were sufficient. And also I have prepared separate video which tells you how to convert AND gate, OR gate and inverter into only NAND gate and only NOR gate. There you'll understand how to convert them. So here you can see I needed 6 NOR gates, whereas in case of NAND gate I need only 2 gates. So of course power dissipation is less in case of NAND gates, whereas here power dissipation is more. So thank you so much for watching. Don't subscribe to my channel. Please like, share and subscribe to my channel. Thank you so much for watching.